Okay, so let's have a look at some more exponential questions, right? So you can see on the screen that I've given you some examples of equations. So let's just have a look at, let's have a look at the first one together. So 5 part A. So we've been given that 3 to the power of x is equal to 12. Okay, so 3 to the power of x is equal to 12. How would we solve something like this?
Convert 12 to 3 all the power 3.
Okay, so we were after the power, aren't we? So we want to find what x is, which in this case is the power. So how are we going to convert this, which is currently in exponent form, so that we can find what x is?
We do the 12 in indices.
Okay. Tell me more. So we don't use indices, do we? We use logarithms. So if you want to find a power, you use your logarithms. Yeah. What's the base?
3.
Good. And what's the number?
12.
Perfect. So can you work out how to stick that in your calculator for me?
That's just 1.0.
Can I quickly just see what you've typed in your calculator?
Log.
Okay, so not quite. So what you've typed in your calculator there is you've just used the log button. You should see on your calculator a button that looks like this. So a button that literally looks like this with empty spaces for a base and for your answer. Can I see? Yeah, that's the one. So what did we get? 2.26, perfect. 2 decimal places, obviously, yeah, good. So yeah, so try and make use of this button over log button. The log button is just basically log to the base 10 on your calculator. If you're talking about it in maths, it should be log to the base e. So try and make use of this one over this one, okay? Try and make use of this one. Okay, perfect. All right, what about if we wanted to solve something like this, or something like 5g? So let's have a look at 5g together. We've got 7 to the power of 2x plus 4 would be equal to 12. How would we solve something like this?
Is this with log again?
Good. So can you tell me what you'd write down?
2x plus 4 log 7.
Hmm?
Just 12.
Okay, so 2x plus 4 is equal to that, isn't it? Because remember, the whole point of a logarithm is that you're making this the subject. You're making the power the subject. So yeah, so it'd be log to the base 7 of 12. Okay? Now before you type that in your calculator, you see with question 1, we just got x on its own when we converted it to logarithm format. With this question, when we convert it to logarithm format, we haven't got x on its own. So I think before you stick it in your calculator, because by the way, whatever you stick in your calculator, 9 times out of 10, that logarithm will be a horrible number, like it will be irrational, which means that you're going to have to end up rounding at some point. So I think it makes sense to stick it in your calculator once to increase the accuracy, rather than sticking that in your calculator and then trying to work out what x is. Work out what x is just with this kind of big horrible thing here, then stick that in your calculator. So, if you want x on its own, what are you going to have to do?
Take the 4.
Mm-hmm.
That's 5.
Yep, so log to the base 7 of 12, take away 4.
Yeah, and divide them by 2.
Excellent, well done. So divide all that by 2. So what I mean is, rather than just sticking that in your calculator, because then that'll be a decimal, which you'll have to divide by 4 and divide by 2. So take away 4, divide by 2. Stick all of that in your calculator, see what you get.
-1.36.
Negative 1.36. Perfect, well done.